Now, for this question, question 11, is going to ask us what the speed of the pellet is when it strikes the wooden block. And the first thing that you've got to look out for is how many marks it is. I think because I didn't leave a lot of space at the bottom of this page, it threw people off and they thought maybe it was a 1 mark question. But when you see a 4 there, you've really got to look out for these every time. It's a 4 mark question. It's not going to be a 2-minute job. It's going to take you, expect to take 4 to 5 minutes over this just to work this out. So let's work this out. We know the block's going to rise to the height of h. Okay, so we can back work this to work out what the kinetic energy was when it was there. So we know this pellet hits it, then it moves the block starts moving with the pellet inside it, and it's got kinetic energy there. It swings up and it turns to gravitational potential energy there. So the first thing we can say is that the mgh is going to be equal to the half mv squared, and we know we've got mass on both sides, so I'm going to get rid of that straight away. I'm going to reverse this back now. I'm going to say that 2gh square rooted is going to be equal to the velocity at that point there. So let's plug in some numbers and find out what the velocity was down here. Okay, there we go. So we're going to need 2 times by 9.81 times by the height, which is 0.63, and I'm going to need to square this lot, or square root this lot, and that's going to give me a velocity of 52 or something like that. 2 times 9.81 times by 0.63 equals root answer equals 3.5 ms to the minus 1. Happy days. Now, if this was a 1 mark question, you might, or a 2 mark question, you might get away with that giving you the thing. And if it said to you, determine the speed of the block when it's at the initial position, then we'd be finished here. But we're not finished here because it wants to know what the speed of the pellet was when it strikes the wooden block. So we can say, well, we know that this was going off at this velocity, and as soon as the block hit it, let's work out what the speed of the pellet was. And in order to do that, we're going to need to think about the momentum. Okay, so what I'm going to say is mv1, momentum before, m1v1 is equal to m2v2, the momentum afterwards. And in this case, we can do this just in grams. We don't even have to change it into kilograms if we don't want to. Let's do it with grams. 8.8 grams times by v1, that's the speed of the pellet, is equal to the mass of the block and the pellet together, which is 450 plus 8.8 times by v2, which is of course 3.5 times by 3.5. Alright, there's only one unknown, and that's velocity. So here's how you do it. 450 plus 8.8 equals, that gives the value, times that by 3.51. That's going to give us that number, and divide that by 8.8, and that's going to give us 182 meters per second. There we go. 182, about 183, round it up properly, there we go, 183. And if you really want it to be truthful, that's the 3 sig figs there, which means, because that's the 3 sig figs, I'd give it to 3 sig figs. There you go, 183. Alright, that's the first one. That's part of it anyway. Okie dokie. Now, discuss how the height of the steel block, the height the steel block reaches compared to the height of 0.63 reached by the wooden block. In your answer, compare the energy and momentum changes that occur in the 2 experiments. Okie dokie. Let's think about momentum first. Come on. Okay. What can we assume to happen when we put a steel block in there? It's going to bounce off. Okay. It's going to do a bit of bouncing off. So the block, the pellet, will rebound. It will rebound from the metal block, yeah? So we'll have negative momentum. if that is the case, in order for momentum to be conserved, that steel block has got to be going forward after this collision faster. Okay, so the momentum of the pellet before is equal to the momentum after. So let's just suppose this was, I don't know, just give it a value. Let's just say it was 10 kilogram meters per second. And then afterwards it's bouncing that way with a value of, let's just say it's -5 for the sake of argument. Okay, then in order for the total of momentum afterwards to be equal to the total momentum before, if we had a net of 10 before and we got -5 over here, this is going to have to be plus 15, okay, in order for the conservation of momentum to hold true. So if this has got a negative momentum, then steel block must have more mom. Okay, that's the first thing. Therefore, it's going faster. Okay, because of this, we say therefore steel is faster than wood. Therefore, steel has more kinetic energy. Okay, so it's going faster, it's got more kinetic energy. If it's got more kinetic energy, I'm going to say now, therefore, the KE will convert into GPE. KE converts to GPE, so steel is higher. Steel goes higher. Or words to that effect. What a lot of people are struggling with this question, a lot of people forget, they're thinking that kinetic energy must be conserved. Even if this was it's not a perfectly elastic collision, but it's more elastic than a pellet going into the wood. Okay, if a pellet goes in and stubs into a wood and gets stuck in it, that is a perfectly inelastic collision, and if it rebounds, it's got some degree of elasticity. And the only way it could be a perfectly elastic collision is if there's no loss of kinetic energy. Now there will be, because the pellet, whatever it's called, the pellet will be deformed, it'll be squished, and so it won't be a perfectly elastic collision, but it'll be more elastic than the block squishing in, which means we're not going to waste as much energy. I mean, if you've ever tried getting a bullet, and I hope you haven't, but if you've ever tried getting a bullet and hammering it into a bit of wood, there you go, that's a bullet and some wood, by the way. If you ever try pushing a bullet into some wood, you'll know that it takes some energy to do it. And that energy must have come from the kinetic energy of the bullet. Therefore, that use of switching a bullet into the wood is where the kinetic energy's gone. If it hasn't done that, in the case of a metal block it won't do that, it's going to be more elastic. Which is going to give you a more accurate value for the velocity of the pellet. Well, the problem here is if we had a steel, we're going to have to calculate, we're going to need to know the velocity of the pellet afterwards, because we can't just do it from conservation of momentum, because we don't, in order to do conservation of momentum, we need to know the velocity which the pellet rebounds at. Okay, so the one that's going to give us the one's going to be easiest and therefore the best of doing accurately will be the wooden one. Okay, so if we said the wood, that's the answer we're looking for, and it's because you only need to measure vel of one thing, which is the block, and the other thing is it's going quite slowly, yeah? It's quite slow, which basically means you can measure its velocity more accurately, more easily. If you had a steel block, A, the steel block's going faster, which means it's harder to get an accurate measurement of its velocity, and B, you've got to measure the pellet that's spanging off in the other direction, and you've got to measure that accurately, and it probably won't be going in a horizontal direction. You have to take the component of it and all sorts of stuff. But essentially, that's your answer there. Alright, I'm going to make another video for this next one.